Over the last couple days, students investigated the external and internal parts of seeds and learned how those seeds are the start of a plant's life cycle. In Lesson 3.4, students plan and carry out an investigation in which they will plant and observe bean seeds to answer questions about how plants grow from those seeds. For materials, Lesson 3.4 requires plastic cups, potting soil, craft sticks, and lima, pinto, pea, and garbanzo bean seeds, all of which can be found in the science kit. Students should also have access to pencils, crayons, and tape or glue. Lesson 3.4 begins with the teacher reviewing those magic beans from Jack and the Beanstalk. The teacher then wonders what type of bean Jack most likely planted. Similar to the previous lesson, Lesson 3.4 has the teacher deliberately taking time to design this investigation with students rather than just assign them a procedural set of instructions. The lesson plan provides several guiding questions and ideas for this discussion. And I'd also recommend sharing the story "The Magic School Bus Gets Planted," as this story models students carrying out a relevant, albeit a fictional, investigation on plants' needs in order for those plants to grow. Jack and the Beanstalk is also featured in the story as the play that the students are putting on in the Magic School Bus story, which is a great coincidence. Physical copies of the Magic School Bus story were distributed to first grade teachers at Science OER trainings and at new teacher inductions. An animated version of this story can also be found by searching for it on Discovery Education. Note that in the story, Miss Frizzle explains that roots only extract water from the soil, which is a bit of an oversimplification, because the roots will also absorb dissolved nutrients from the soil that are dissolved in the water. After the story, remind students that they are about to conduct a similar investigation to what the characters in the Magic School Bus did. And at this point, the teacher can review the steps that students should do in the investigation. Ultimately, we want students to arrive at the idea that for their investigation, they will need to label and plant their seeds in soil, and then over time, they'll need to measure the height of the plants that grow to determine which of those plants is the tallest. As I was planting the seeds for this video, it dawned on me that it is also important to consider using an equal amount of soil in each cup, and to plant each bean type at a similar depth in the soil. I'd also recommend using about 3 to 4 seeds per cup of soil and planting them about 1 inch deep. I placed 1 seed in the center of the cup, and then I'll place 2 seeds about 1 inch deep along the outer wall of the cup. So I'll plant one on the side facing towards me, one side in the center, and then about, opposite, about 180 degrees, I'll plant that second seed. And each of those seeds is about 1 inch deep. By planting those seeds on the outside of the wall of the cup, hopefully we can actually see a sort of cross-section of the soil as the roots and the stem emerge from the seed. Now that the bean seeds are planted, the cups should be stored and maintained with additional water over the coming days. Students can use the included label sheet with this handout in this lesson, and they can glue the label sheet to a craft stick and they can insert it into the cup so that each of their beans is properly labeled and they know at all times which plants they're looking at, which type of bean seed. Consider for future days setting aside a few minutes each day, maybe in the morning or at the beginning or end of your science lesson, to provide regular opportunities for students to observe, measure, and record the heights of their plants in their student notebooks. Students' plant data will be the focus of 2 later KIT lessons, Lessons 3.7 and Lesson 3.8. Furthermore, this investigation will be referenced in the Quarter 4 Science Kit, How Does It Grow?, when students are conducting additional plant experiments, and they'll come back and reference this experiment when they're conducting those later experiments.